Breath of a second, frame of mind, between every moment, an image to find. Perfect composition, presence is kind, suspended in air and frozen in time.
So first things first, going through, this is our carabiner press room.
Okay, cool.
Our carabiner is made in basically 3 different processes. We call it bend, smash, and trim.
Okay.
So we'll start here. This is our raw rod stock. We start out with our carabiners with just 12-foot bars of aluminum. So the first process is our bend process. So we take these large pieces of 12-foot rod stock and we need to bend it into our general shape of our carabiner. At this point, the material is really soft. A different carabiner will go through a different process depending on our style. Our positron carabiner that we're creating right here is a cold forge style. We take cold rod stock, we put it into a cold die, and we just smash it with about 150 tons.
150 tons.
That's a 150-ton machine right there.
Wow. That's hard to even imagine how much force that is.
You don't want to put your hand in there.
Yeah. It'll come out of carabiner. Yeah.
We try to keep the carabiner flowing through the process as quick as possible. So if you notice also, the carabiner will come out the back of the machine.
Yeah.
To our next process.
So now we've bent the aluminum. We stamped it into the basic shape. We've trimmed off the nose. So now what happens?
Yep. So the next part is heat treating.
Okay.
So now we created a carabiner body that's our final shape.
Yeah.
But it's such a soft material at this point. We gotta heat treat it to make it real strong and to our final product. We put everything together. We mixed it all up. We've got the dough. We shaped it, and now what we want to do is actually bake it.
Yeah, totally.
So the next step is we want to take the tumbling, where we can roll all those edges over, get rid of this black film that's on the outside or black surfacing on the outside, and then that makes it real smooth.
The breaking of stuff is not just for functionality. You know, the carabiner needs to be of a certain strength, but not only is it important for functionality and safety standpoint, it's the way that we can verify that the manufacturing processes are in control. Yeah. That there's consistency.
Glue it back together, it'll still be good.
That was 5,465 pounds. So that was almost 25 kN.
25 kN is
25 kilonewtons is 5,400. That was 5,465 pounds is what that broke at. And
so you could hang a few cars off this.
Yep, in a pure static load scenario, you could hang a couple of cars off that at least, you know.